Hi guys, welcome to the post-contest discussion of Codeforces Round 964. This is TLE Eliminators and I am Abhinav Kumar. So let's get started with the first problem. Okay, so the first problem that we have is the problem A, where given a two-digit positive integer n, find the sum of its digits. So basically we are just given a positive integer n and we need to find the sum of its digits. So it's a very simple problem. So let's just see what we can do here. So if we are already given that we have a two-digit number. So if let's say it's 12, we just need to find 1 plus 2 equal to 3. That's what we need to do. So like one basic solution for that is if n is, let's say, somewhat 15, to get the ones place digit, you can do n modulo 10. This would give you the ones place digit, and n divided by 10 would give you the digit at the tens place. So if it is 15, so 15 modulo 10 would give us basically 5, and 15 by 10 would give us 1. So we can just add 5 plus 1 and get 6 as our answer. We can just directly do that. Uh, so like for a two-digit number, we can just directly write it n modulo 10 plus n by 10 as our answer. But let's see the code. Like in my code, I have done for a general any digit number. So I've taken a while loop and extracted each digit by doing n modulo 10 and then n by 10. So yeah, like I could have directly written here C out, because here in the question I'm given it's a two-digit number. I could have directly written n by 10 plus n mod 10. This would also be fine. This was not required. But like during the contest, I did not notice that. So it's a general solution for any digit number to find the sum of digits. So this is a general solution if you are given a number and you just need to find the sum of its digits. So run a while loop until n is greater than 0. So when n becomes 0, you would come out of the loop and just add to the sum n modulo 10. It would extract the last digit and divide n by 10. So I think this is a very basic problem. So uh, I think voice and all is clear. If there is any problem, you can tell. Okay, so we can move to the next problem now. Yeah, okay. Okay, so let's move to the next problem. Sunit and Slavik play a card game. The rules of game are as follows. Each card has an integer value between 1 and 10. Each card receives two cards which are face down, so a player doesn't know their card. The game is turn-based and consists exactly two turns. Okay, so basically I'll tell you what the question is. So in the question, we are given four values, A1, A2, B1, B2. So what does those four values represent? Okay, so what we are given four values, A1, A2, B1, and B2. So these represents the face at, so basically there are two players. A player one receives two cards, and player two receives two cards. That's what we are given. And for the two cards that player one receives, the value in the face of the cards are A1 and A2 for the first player. So let's say this is player one, uh, the first player, and for player two, the values are B1 and B2. That's what we are given. And now how they are playing. So first, the first player would just select any one of his cards. Let's say he selected A1. So he would select any one of his cards, and the second player would select any one of his card and turn it up. So, and then let's say he selected A1, the other player selected B1. And when they turn them up, if A1 was greater than B1, if the value for the first player was greater than for the second player, then player one would win. If value for the second player was greater, then player two would win. If the values at both the cards are same, then it would be a tie, and none of the players would receive a point. So whichever player wins would receive a point. Then the in the second round, they would turn the other card up. So let's suppose in the first round, let's suppose the values given A1 was 2, A2 was, let's say, 3, B1 was 5, B2 was 7. Let's suppose we are given this. So if in the first turn, the player 1 chooses the first card and it turns out to be 2, in the first turn only, the player 2 chooses the first card, it turns out to be 5. We would compare, this was greater, so player 2 would receive 1 point. Okay. And in the second round, the remaining card was this A2 and the remaining card was B2. So 3 and 7 would be compared. Again, player 2 wins here. So player 2 receives 1 more point. The total points finally was 2 for player 1, player 2, and 1 point for player 1. So player 2 has more points. So player 2 wins in this condition. Okay, that's what happens. Now, what we need to find is uh, for all the possible scenarios of the game, in how many scenarios would player 1 win? That's what we need to find. So, how many scenarios can we have? So, what can we have? Let's say player 1 selects, let's say player 1 selects A1, player 2 selects B1, and then the remaining would be A2, B2. This would be one possible scenario. Okay. Other possible scenario would be player 1 selects A1, player 2 selects B2, and player 1 would select A2 in the next round, and player 2 would select B1 in the next round. This is second scenario. The third scenario can be player 1 selects A2 and then player 2 selects B1. So A1, B2. This would be the third scenario, and then A2, B2, A1, B1. So only these four scenarios can occur. Okay. And we just need to find among these four scenarios, in how many scenarios would player 1 win? Would A win? That's what we need to find. In how many scenarios would player A win? Okay. So we can just directly, you can see, we can just directly check for all the four cases. And if you look closely, actually, we don't need to check for all four cases, because if you see this case and this case, are they not the same? Because if in the first round we are comparing A1 with B1, in the second round we are comparing A2 with B2. Here, first round A2 with B2, second round A1 with. So finally, we are adding the scores of both the round. So for these two scenarios, if player 1 is winning, then in this scenario also player 1 would win. If player 2 is winning, 2 would win. Or if it is a draw, it would be a draw. So basically, these two scenarios are same, and the same way these two scenarios are also the same, because A1 compared to A2, A2 compared to B1, A2 compared to B1, A1 compared to B2. So actually, if you look, we just need to check for this scenario and this scenario. If player 1 wins in this scenario, add a +2 to the answer. If player 1 wins in this scenario, add another +2 to the answer. That's it. You just need to do check for these two scenarios. Okay. So let's just see how can we check. So for the first scenario, let's name it scenario 1 and scenario 2. For the scenario 1, we just need to check if A1 was greater than B1 and A2 was greater. Let's say A1, A2 both were greater than B1, B2. So player 1 would win both the rounds and player 1 would win. That's one case. Or it may happen that player 1 wins one of the rounds and one of the rounds gets tied. That would also be okay. So, and if both the rounds get tied, then both of them would be at 0 points. So player 1 would not win. A tie is not counted as a win for any of the players. Okay. So the only way player A can win is if A1 is greater than B1 and A2 is either greater or equal to B2. That's one case. Or if A2 is greater than B2 and A1 is either greater or equal to B1. So if either of these two happens, so if either this case happens where A1 is greater than B1 and A2 is either greater than B2 or equal to B2 is also okay. Or this happens where A2 is greater than B2, so player one wins one of the round, and the other round either he wins or draws. It doesn't matter. Okay. But if he wins one round and loses another round, then again it would be a tie. So he would not win. So for him to win, he need to win one of the round and draw one round or win both rounds. Okay, so this is the condition we can write for uh, player A to win in scenario one. Same way for scenario two, what we can write. So this is the scenario two. So here for player one to win, player A to win, either A2 should be strictly greater than B1, and then it doesn't matter. A1 should be just either greater than or equal to B2, or A2 should be greater than equal to B1, and A1 should be greater than B2. So either of these two conditions should be satisfied for player A to win in scenario two. Okay, like, did you get what I'm trying to tell? Um, okay. Okay, so we can just now what we need to do, we would just check for this condition. Either this is satisfied or this is satisfied. If any one of this is satisfied, add a +2 to the answer. If any one of this is satisfied, add a +2 to the answer. Whatever we get, just print that. Okay, because if scenario one, if player A wins in scenario one, he's going to win in both of these cases. That's why I'm adding a +2. And if he doesn't win, then just no need to add, just add a +0. Okay, so I think it would be clear. So we can just look at the code for the second question. Okay, so I just took the input here, and then I just checked that condition that I told you there. A1 greater than B1 and
So
A2
here
greater
we
than
are
B1.
just finding the possible combinations. Am I correct?
Yeah. Yeah, there are
Okay.
only four possible combinations, and in that also we just found out that these two are the same and these two are the same. So we are just checking for this and this. Okay.
Okay, I thought we had to use I thought we had to use combinatorics or probability for this.
No, like, because there are only four combinations possible. If
Uh,
there would have been more than that, then we would require some PNC. But here we can manually check the four combinations. Uh, okay, so I hope that is clear. So we just checked either this condition is satisfied or this condition is satisfied, then add a +2 to our answer. And if this is satisfied or this is satisfied, add a +2 to the answer and print answer. So I hope the problem is clear now. Y greater than equal to, so like, if you didn't understand that, so for player A to win, either he should win one game and draw one game, draw, win, or win both. Only these, in these three cases, a player A can win. If it is a win and a loss, it would be a tie. A loss and win would be a tie. Loss would be a loss. Okay, or draw would also be a draw. Okay, so these cases are not valid. Only valid cases are win draw, draw win, and win win. Okay, so for win win, both should be strictly greater. Both strictly greater conditions should be satisfied for win win situation. uh, Strictly greater and strictly greater. For draw win, greater than equal to and strictly greater. So this greater than equal to and strictly greater. This is for draw win. For win draw, strict for win draw, strictly greater and greater than equal to. So with these two conditions, we are checking for either of these three cases. I hope that is clear. Y plus 2, as I explained earlier, because for this case and this case, both are same. So there are actually four scenarios, but we are checking only two scenarios. If this, in this scenario, player A wins, then we are sure then that in this scenario also player A would only win. So that's why we are directly adding +2, that in both these scenarios, player A is win. The order just doesn't matter. You can take the order of the inputs only. Okay. Whatever the input is given, A1, A2, B1, B2, you can just take that. Even if you flip, because we are considering all the scenarios, so order doesn't matter. Okay. I hope this problem is clear. We can move to the next problem now. Okay, so as a computer science student, Alex faces a hard challenge, souring. He tries to sour daily, but despite his efforts, this that. So what actually in this problem we are given some intervals. So let's say this is so we are given an array of intervals. You can just assume like this. So there is m minutes in a day. Okay, so a day has m minutes. We are given the value of m, and uh, in those m minutes of the day, so if this day has 10 minutes, it's drawn like this. We are given some intervals. The first interval is 3 to 5, so you can just look at it like this. So let's take the first test case and explain you. Okay, so what you are given, this is m, this is s, this is n. So n is just the number of intervals, so there are three intervals. I'll tell you what s is. M is the number of minutes in a day. So let's say there are 10 minutes in a day. So we can draw a number line representing those minutes. So this is the 0th minute, this is the 10th minute. And what we are given, let's just write it. So what we are given here is, we are given some intervals. First interval is 3 to 5. Let's mark it. 3 to 5 is an interval. Second interval is 6 to 8. Let's mark it 6 to 8. Third interval is 9 to 10. Let's mark it 9 to 10. Okay, so we are given some intervals. What we need to find is in this in among these intervals. So it just means that the person is busy in these intervals, and he need to find a free time to maybe take a shower, and that free time should be at least 3 minutes. Okay. Uh, so we just need to find, can he take that shower in that day? Does he have a continuous 3 minute of free time? We just need to find that. So whatever intervals we are given, it just means that he is busy during that time. He cannot take a shower during that time. So we just need to find whether there exists a continuous 3 minute interval where he can take a shower. So what we need to do, we just need to check the free time, the extra time. So from 0 to 3, there you can see at the start we have a 3 minute of free time where you can take a shower, or we can just look at this interval. It's a 1 minute interval. This is also a 1 minute interval. So basically the free intervals we have are, here we have a 3, here we have a 1, here we have a 1. So if we can find all the gaps that we have and just check if any one of the gap is greater than s, then we would return yes, he can take a shower. Otherwise we need to return no, he cannot take a shower. This is what the question is. Okay. So what we can do here is, uh, we just need to find those intervals. So we would start with the first interval. Uh, the first interval, if it starts from 3, so this 3 would represents the at the before the first interval, the gap before the first interval. So the gap, we would just take the gap before the first interval. Okay, and then we would take the gaps in between intervals. So 6 minus 5, you can see this. So 6 minus 5 would give me the gap between these two intervals. Same way, 9 minus 8. 9 minus 8 would give me the gap between these two intervals. And after 10, if let's suppose m was 11, if m was 11, we would have one more interval of 1 minute here. So we would also check uh, m minus the last interval. This would give me the final gap. Okay. So m was 10 years, so it was 0 only. Okay, so we would just check all the intervals. We can just take the maximum among those intervals. And if that maximum is greater than S, then we would say, yes, we can take a bath there. Otherwise, we would say no. Okay, I hope it is clear. Yeah, and to store those interval, we can use a pair to store those intervals. So you would look, we would look at the code, how we are doing it. Okay. So we have taken the input NSM, and we are storing all the intervals in a vector of pair. Okay, we have taken a vector of pair of size n. So interval of L and R, we have taken the input, and in the vector, we have stored that pair. Okay. So the first gap would be before the first interval. So what is before the first interval is the start of the first interval would give us the first gap. Okay, vec 0 dot first. That we would just initialize our max with, and then we would just maximize for all the intervals. Start from the second interval. So I equal to 1 is second interval for a zero based indexing, and just start of the second interval minus end of the interval before that. This would give me the gap between the two intervals. So I'm trying to maximize this gap. Okay, in MX, I would store the maximum gap. And the last one would be M minus the end of the last interval. That also we would maximize. So in MX, we have stored all the empty gaps that we have, the maximum gap we can have. If that maximum gap is greater than S, we would say yes. Otherwise, we would say no. Okay. I hope this problem is clear. Okay. Can you explain the code again? Why not sorting? Okay, for sorting, we are already given in the question that it is sorted according to time. If had we been given that it's in random order, then we would sort them first. But here you can see the additional constraint we are already given. Li is greater than Ri minus 1. So every next interval would start after the end of the previous interval. That's what it means. So it's already given in sorted form and non-intersecting form that we can understand from this constraint. So we don't need to sort it. If it was not given, we would sort it first. Uh, okay, so in the code part, some people are having a doubt. So I'll explain that again. So a pair basically just means if you are not aware about it, in a pair we just store two values. So uh, we have taken a vector of pair. So every element is a pair L comma R. So dot first would give us the first value and dot second would give us the second value. So that's what we are doing. So we have stored all the values in the form of a vector of pair. And then we are iterating through every value. So what was the gap that we had? The gap we had was the start of the next interval and the end of the previous interval. This was the gap. So if vec I represents this interval, then dot first would give us this left side, and vec I minus 1 would represent the previous interval, and dot second would give us the end of that. So difference between these two is what the gap is. That's why we are subtracting from this minus this. That's why we are doing vec I dot first minus vec I minus 1 dot second. If you look at this code, vec I dot first minus vec I minus 1 dot second. So I hope this is clear how we are taking the gaps and before the first interval, after the last interval. These two also we are considering. Okay. So I hope the third problem is clear. So we can move to the fourth problem now. Okay. So Salvik has a very tough exam and needs your help. Okay, please don't do that. Whoever is doing it, I'll have to disable it otherwise. Okay. What we have here, Salvik, he is struggling with a question. So in this, we are basically given two strings, S and T. And what we need to do, okay, let's see what we need to find out here. Okay, so we are given two strings, S and T. So T is smaller than S. So what we need to do is we need to make T as a subsequence of S. So let's suppose in S we are given A, B, C, question mark, T, question mark, F, something like that. And here we are given B, C, E, F. Okay, let's suppose we are giving this text case. So what the question is saying that in S, we have alphabets from A to Z and some question marks. So question mark just represents some missing alphabets, some missing characters in the string. which we can replace with our own character, whatever we wish to. Okay, that's what the question mark represents. And the T represents, T is a complete string. Here we would not have a question mark. A question mark would not be present here. So T would have only alphabets from A to Z. Okay. So what we need to find is need to make T as a subsequence of S. What does a subsequence means? A subsequence basically means that T should have, so T should basically be like a subset of S and having the same order. So what I mean with that, so if let's suppose in S we have A, B, D, C, E, D, F, something like that, and what would be the subsequences of that? Let's say we take A, we take C, and we take D. So A, C, D would be one possible subsequence, or we can take B and E and D. So B, E, D would be one possible subsequence. So we can either uh, take any element or not take any element. Like this, if we just take a subset of that string, that's what we mean by a subsequence. So it should follow the same order. So A is here, then C should be after A, D should be after C. Same way, if B is here, E should be after B, and D should be after E. That's what a subsequence means. So what we need to do is we need to fill in these question marks such that T becomes a subsequence of S. Okay. And if we can do this by filling with some characters, then return a yes. If we cannot do this, then return a no. That's what the question is asking me to do. Okay. So how can we do that? So let's, what we need to make? We need to make T as a subsequence of S. So what property should S satisfy? So if we have a B, we can just start checking where we get the first B. Here we have a B. Okay, so we can just link these two. Now we need a C. So after B, we would start searching for a C. We can link these two. We got a C. Then we would search for an E. While searching, we didn't find an E. So what we could have done is replace this question mark with an E. So we can link this. And then we would search for an F, F, F. Here we got an F. We can link this. So basically what we need to do is just start from the first character of T and try to find that character. Wherever you find that character, you say, yeah, it's matched. Then start with the next character. Try to find that character after the matched character. Okay. So yeah, if you are trying to do this and if you don't find a character, you would have to replace some question mark with that character. And if you don't have any question mark available, then you can just say no. Okay. So what I'm saying is, whenever you are searching for B, what you can do is, uh, even if you just start searching linearly from the start. Okay. So what you need to do is just start searching linearly from the start. You are searching for B. If you get some character which is not a question mark, you cannot replace it. So just move ahead. If you got an A, yeah, this is not B, move ahead. You got a B. Okay. So move, you are taking two pointers basically, a pointer I for string S, a pointer J for string T. Okay. So you just compared SI with TJ. Okay, so this B was not equal to A. So what you did, you just move this pointer I ahead. Okay, now when you found that both of them are equal, you found a B, then you would move the J pointer ahead as well as the I pointer ahead. You would move both of them ahead. Then you would check if they are equal. Both are CC. So again, you got an equality. You would move the J pointer ahead, I pointer ahead. Okay. Here you had a question mark. Okay. Now, next you found E. You need to search for E, but you found a question mark. So what you can do, you can just replace that question mark with an E so that you can match both of them. Okay. So whenever you get a question mark, even maybe instead of D, let's suppose you had an E. Okay. So you would say, instead of replacing this question mark, I can match to this E. But what is the problem if you replace this question mark to E? You have to anyways replace this question mark with some character. So replace it with E, because after that, if you are searching for F, and you got an E, you can ignore that and move ahead. You already satisfied the condition for E. So for searching for F, if you matched with this E, you would search here. If you matched with this E and replaced it with a question mark, the question mark with an E, you would search here. So if you had to get an F here, you would get with this also, with this also. So like, I hope you're understanding the intuition why I'm saying that even if you get an E after that, still if you have a question mark, just replace it with whatever character you are needing. Immediately replace it with whatever character you need and just move ahead. This way, if you just do greedily, you can just check. And finally, if you can replace every, you can just find a match for every character in T. You can say, yes, you can do it. Otherwise, you would say, no, you can't do it if you don't find a match. Okay, I hope this is clear. I'll dry run for one more test case. Let's suppose so you have what we are doing in the algorithm. Let's suppose you have A, C, question mark, question mark, question mark, F. And in T, you have C, B, E, F. Okay. So what we would be doing, we would take a pointer I for S and a J for T. We would check if these two are same. A is not equal to C, so we would move I ahead. Okay. And now C and C are equal, then we would move both J and I ahead. Okay. So we moved I ahead, again we moved J ahead. Now we are searching for a B and we have a question mark. So we would replace this question mark with B and we would say we found a match, move I ahead, J ahead. We are searching for a E, we got a question mark. We would replace this question mark with an E and we found a match, move both I and J ahead. We are searching for F and we have a question mark. So replace this with F, move both J and I ahead. Once this J goes out of T, then we have found all the matches. We can just print yes. And along with printing yes, we also need to print the S which would satisfy this. So what S satisfies this? After replacing the question marks, we got AC, PEFF. So this would be one possible string which satisfies that T is a subsequence. So we, along with yes, we can print this string. Now let's suppose you had a question mark here. So you need to have a string S without any question marks. So you can replace this question mark with any character. So for the remaining question marks, if you have some question marks left in S and you already have traversed the whole T, you have already got a yes, then you can replace those remaining question marks with any character of your choice. Let's suppose we replaced it with A. So you can just have A there. A, Z, B, anything you can have, because we only need to find one possibility of a string which satisfies this. Any possible possibility which satisfies this is okay to go with. Okay, I hope this is clear. And uh, let okay, let's see the code here now. If you have any doubt, you can ask then. So here what I'm doing, I just took both the strings as input and I calculated the size of S and size of T in N and M. So I represents, I is the pointer for the string S and J would be the pointer for the string T. Okay. So we are moving J linearly from for all the characters of T, and inside that, until I is less than N and they are unequal. So if we have something like uh, Si and Tj are unequal, then what we need to do? We need to move our I ahead. But before that, we would check if Si is a question mark, then we can just make Si equal to Tj. We can make them satisfy the condition and break out of the while loop. And we would say, yeah, they are equal now. And if it is not, if it is some other character, we would just do I plus plus and check for the next character. So in this while loop, we are handling the I pointer. And if I reaches N, so if I is less than N still and they are equal, we would move I plus plus and J would automatically, we need to do I plus plus and J plus plus, both of them. So J is would automatically get plus plus when it would move to the next loop. So this is satisfied. Otherwise, If I has moved to n, so we have moved to the end of my string, and still they are like not, we are not able to satisfy this condition, or we are not able to traverse the whole t, then we would just see out no and return out. We would, at that time only, we would say no, we cannot do this. Okay. And we would return. Okay. So in this for loop, if at some point you get the else condition, you would print no and return out. If not, then we would say that yes, we have, we are able to cover it. So we would print a yes. And then if I is less than n, we would just traverse the remaining string and check if there is some question mark. Replace that with any character of your choice. It can be a, or it can be any character of your choice. Just do that. So if there is some question mark left, just do that and then print your string yes. So this way, this would be the code. I hope everything is clear for this question. Okay. So now we can move to the next problem, which is problem E. Okay, so here what we have on the board, IV wrote down all integers from L to R inclusive. In an operation, C does the following. Pick two numbers X and Y on the board, erase them, and in their place write the numbers 3X and Y by 3, where this denotes rounding down to. So it's basically the nearest rounding down, C floor of Y by 3. That's what this symbol represents. What is minimum number of operations IV needs to make all numbers on the board equal to 0? And we have a proof that we can always do this. So let's understand what we need to do here. So you are given two integers L and R. Okay. You're given two integers L and R. Let's suppose L is 1, R is 3. The first test case was this. It just means that the person would write down all the integers in the range from L to R. So he would write down 1, 2, 3. So basically all the integers in the range from L to R would be written down on the board. So he has written down all the numbers. Then what he can do, in every operation, he would select an X and a Y. So he would select two numbers. Let's say he selected this as an X, this as an Y. So after selecting this, what he would do is he would make X to go as 3X. So he would replace X. So if he had selected this as an X, this as an Y, then he would replace X with 3X. He would make 2 as 3 times 2, which is 6. And he would replace Y with Y by 3 floor of that. So 3 by 3 is 1, and floor division for an integer would remain 1. So 3 would be replaced by 1 if we select this X and Y. If we select X equal to 2 and Y equal to 3, after the first operation, our new numbers on the table would be this 161. So this is one possibility of an operation. So likewise, he has to apply these operations and finally reduce these numbers. So apply the operations and finally reduce these numbers to all zeros. That's what he need to achieve. And he need to achieve this result in minimum number of steps. So in minimum number of operations, he need to achieve this result. So that's what the question is asking from me. Okay. So how can we do that? First, let's understand, would it always fall to 0? How can we make it fall to 0? So the first thing is, if we are replacing an X with 3X, it's always increasing. So by replacing any X with 3X, we are increasing the number. So this is not going to make it fall to 0. What can make a number fall to 0 is replacing Y with Y by 3. This can make a number fall to 0 when, let's suppose we are selecting Y as 2. So what would be 2 by 3 floor division? 2 by 3 is 0.667 and floor division of that would be 0. Okay. So any number which is less than 3, when that is selected as an Y, that would fall to 0. What about the numbers which are greater than 3? So let's suppose we have a number 12. Okay. So in one operation, if it is selected as an Y, so 12 by 3 would become 4. If again we select this as a Y, 4 by 3 would floor division would become 1. If again this is selected as an Y, it would fall to 0. So a 12 can fall to 0 in 1, 2, 3 steps. Okay, so any number would, after some number of steps, it would fall to 0. Any number would fall to 0 if that is continuously selected as a Y. So first thing is that we can calculate in how many steps it would fall to 0. In how many steps a 12 would fall to 0. That we can just recursively calculate by dividing it by 3 again and again and just find in how many steps. Okay, we'll see what its complexity would be. Okay, that we can do. But the problem is if we are selecting this as Y again and again, we also need to have an X. For each operation, we need to select an X as well as Y. So if some number is falling, some number would be increasing because that is selected as X. So if we had this 1, 2, 3, how can we make it fall to 0, 0, 0? So one possible scenario is select this as X and this as Y. What would happen? 1 would triple itself and become 3. 2 would fall to 0. It would become this. Now, once we have a 0, what we can do? So if we are selecting some number as X as some 1, it would triple itself and become 3. Now, for this to fall to 0, 1 could have fallen to 0 in one step, but 3 would fall to 0 in two steps. So whenever you are making a number multiply by 3, you are increasing the number of steps it would require to fall. So basically, if you are making one number to fall, you are increasing another number. You are not doing anything. If you see as a whole, you are not decreasing the total number of steps required to fall. But if we have a 0 and we select that 0 as an X, what would happen? 0 multiplied by 3 would still remain 0. So it would be unaffected. So basically, if we make any one number to fall to 0 once, after that work we can do, we can just select this 0 as an X every time so that no number is increasing. So if you select any non-zero number, it would definitely increase. If any non-zero number is selected as an X, it would become 3X. But if a 0 is selected as an X, it would remain 0. So we can take this benefit that if we make just any one number fall to 0, then we can utilize that number as an X every time and make other numbers to fall to 0. So we took this as a Y and made it 1. Okay, then again this X, this Y, this would fall to 0. And now this as X and this as Y, this would fall to 1. Now this as X, this as Y, this would become 0, 0, 0. So you can see in 1, 2, 3, 4, 5 steps, we have made this as 0, 0, 0. You can just see the answer for this first test case, 1, 3, it was 5. So this is what we were doing. Okay, you can see in the example. So what's the best thing we can do in minimum number of steps? How can we it make all the numbers 0 in minimum number of steps? So if we need to find that, uh, so first thing we want to achieve is just somehow make any one number to fall to 0. So what would be the best number to be selected to fall to 0? Because so let's suppose we have a range from 5 to 8. Okay. So if you look at this test case, 5, 6, 7, 8. Okay. So some people are writing minimum element smallest. So yeah, you're right. That if you select, let's suppose this is not 8, this is 9. Okay. So had you selected this 9 to be the first number that would fall to 0, how many steps it would require? This 9 would become 3, 3 would become 1, 1 would become 0. So this would take 3 steps to fall to 0. And while this is taking these 3 steps, some number would increase. So maybe you are taking this as your X, then 5 would become 15, 15 would become 45. Likewise, if you are taking 3 steps, so in 3 steps, if this is falling to 0, then this would also become 5. multiplied by 3, multiplied by 3, like 3 times. Okay. So if after that, if 5 requires 2 steps to fall. So if we divide this by 3, it would fall to 1 and then 0. It would require 2 steps. But this number would require 2 plus 3, 5 steps now to fall to 0. So if we are selecting 9 as our first element, that would become 0. It means uh, if this takes 3 steps, then some other number would increase the number of steps required. So basically, we are taking 6 steps to make it to even out that thing. Okay, like if I'm not able to understand that thing, I would explain with an example. So uh, let's suppose what I am doing here is I'm making this, I'm first trying to make this 9 to fall to 0. So first I would select this as a y and I would need some x. Let's say this is the x. So 5 would become 15, 9 would become 3. Rest would remain same. Okay. Then again, I need to make this to fall to 0. So again, I would select this as y. And maybe let's suppose I selected this as an x. So 6 would become 18, 7, 8 as it is, and 3 would become 1. Again, we need to make this 0. So one more step would be required. Let's suppose I selected this 7 as an x. So it would become 15, 18, 21, 8, and 0. Now, after this, once we have a 0, then always we would select that as an x and remaining numbers as y1 one time. So first we would make this 15 to fall to 0 by selecting it as y again and again. So how many steps would it take? 15 to 5, 5 to 1, and 1 to 0. So 3 steps. 18 would fall to 6 to 0. 3 steps. 21 would be 7, 2 and 0. 3 steps. 8 would become 2 and 0, 2 steps. So basically, if you add them up, this would take 3 steps, 3 steps, 3 steps, and 2 steps. And for making this conversion, we have already done 1, 2, and 3 steps. So in total, we have 3 plus 3 plus 3 plus 2 plus 3 steps that we already did. So this is basically uh, 12 into 14 steps. Okay. Uh, this is one possibility. But what was better that we had selected this 5 to fall to 0 first. So then what would happen? Then if you look at it, let's say you have the test case again, that 5, 6, 7, 8, 9. If you make this smallest number to fall to 0, then 5 would become 1. And let's suppose you took this as y and this as x. So 6 becomes 18. And then 1 would become 0. Let's suppose this is x, this is y, and this is x. So 18 and 21. So in 2 steps, we have made this 5 to fall to 0. Now, for making others, 18 would fall to 0 in 3 steps, 21 in 3 steps. We had calculated before. 8 would fall in 3 steps, and 9 would become 3 to 1 to 0. It would also take 3 steps. So 2 steps here, and 2 plus 3 plus 3 plus 2, you can calculate this would be only 13 steps. Okay. So there you were having 14 steps. Now you are only having 13 steps. 3, 3, 9, 3, 12 to 14. So here you are only having 13 steps. So that's what I'm telling, that you would make the smallest number to fall to 0 first. After that, just calculate how many steps more are required. So what your final answer is, if in your initial array, you can calculate how many steps every element is taking to fall to 0. Then if 5 is taking 2 steps, 6 is taking 2 steps, 7 is taking 2 steps, 8 is taking 2 steps, 9 is taking 3 steps. If you among them, you are making this 5 to fall to 0 first, so you can just double that, because when you are applying 2 steps here, you are increasing any two of them. So actually, it's taking double of 2 for the first number. because it is falling to 0, and in the process it is making some other numbers. Let's say this 6 was increased to 18, this 7 was increased to 21. It is making some other numbers to require more number of steps. So that's why you will multiply the smallest number by 2. So your final answer would be 2 into 2 plus 2223. So this way you can see this would be 13. Okay. So uh, that's what, like, from the intuition and everything, you can understand that your final answer is just going to be the number of steps the minimum number is going to require multiplied by 2. If the minimum number requires x number of steps, you would write your final answer as 2x plus number of steps required for each of the remaining elements. Okay, that's what you would write your final answer as. I hope this thing is clear. Then we would come, how can we optimally calculate that?
Sir, sir, why
Yeah.
2x?
Yeah, that's why, that's what I was trying to explain. If this 5, if this was 5, this 5 was taking 2 steps to fall to 0, then while it was falling to 0, in turn, this 6 was increased to 18, this 7 was increased to 21. So this 6 was taking 2 steps, but now it is taking 3 steps. The
Okay,
7
okay.
which was taking 2 steps is now taking 3 steps. So if some y is falling to y by 3, some x is going 3x. So actually, it's taking the cost of two operations, you can understand in your final answer. Okay, I hope that is clear.
Yes.
Uh, okay, so if you just need to calculate this. Now let's see the constraints and see how we can calculate this optimally. So the constraints of the problem was L and R were in the range from 2E5. And we have T test cases which are 1E4. So if you just, the brute force approach would be what? For every test case, just calculate for every L to R range. So for all I in L to R, just calculate how many steps it would take to fall for L, then L plus 1, then L plus 2, likewise up to R. For every element, just calculate how many steps. Now, in what complexity you can calculate that in how many steps this L would fall to 0. So you can see this L would get reduced to L by 3, then L by 3 would get reduced by 3, so L by 3 square, then L by 3 cube. That way it would get reduced to 0. So finally, you can say that after I steps, L would be reduced to L by 3 to the power I. And we are saying that this is equal to 0. So, or it would get equal to 1, 2, 3, something like that after some steps. So you can say that 3 to the power I is actually L and I is log base 3L. So for any number X, it would fall to 0 in log base 3x steps. You can say that. So if you recursively calculate this, it would take a logarithmic time to calculate for any number that how many steps it would require. That steps can be calculated in log base 3 time. Okay. So log time would be very less. So that is not a big problem. But if you are doing this for all L, for all I from L to R for this full range, this range can be up to 1E5. So, and you have T test cases which are 1E4. So for every test case, if you're calculating, this would go 1E9 and multiplied by some log base 3, some log factor also. Okay, so this would give you a TLE. So I think many people had done this brute force and were getting TLE. So now how can you optimize this? So to optimize this, you can just pre-calculate your answers. So what you needed to calculate? You needed to calculate the sum of, let's say, the number of steps required. Let's name it a function f. Okay. So f of x just returns you the number of steps x would take to fall to 0. Okay. This function would be calculated in log base 3x time. Okay. This would take a logarithmic time. So if you calculate this fx for every x from 0 to 1e5 for all the range, if you calculate this, what you need to calculate? You need to calculate the sum of f. Your final answer was what? As you saw, your final answer was actually f of L, 2 times f of L plus f of L plus 1. This would be summed up till f of R. This was your final answer. So you just need to calculate. If you have calculated the value of this function for every index from 0 to 1e5 for all the values, then you just need to take the sum of this. So you can use the concept of prefix sum, if you know, to calculate this sum of this range in O of 1 if you have pre-calculated this before only. So before the test cases only, if you pre-calculate the sum for any range. So if you have pre-calculated your prefix sum, so prefix of I just represents the sum of f of 0 to f of I. If you pre-calculate this prefix of I, then you can just write your final answer as 2 times f of L would remain, but this sum can be written in the form of prefix of R minus prefix of L. So prefix of R would be sum from 0 to the sum from 0 to R, and you subtract from 0 to L, you would get the sum from L plus 1 to R. So this would give us the sum from L plus 1 to R and 2 times of L. So if you have pre-computed the F for every value and then a prefix array for that, then you can compute your answer in O of 1 time. Or if this is taking a logarithmic time, that is also not a problem. So T into O of 1 time would be sufficient in 1e4, and the pre-computation would take 1e5 into log base of 1e5. So this plus this would be your overall time complexity if you pre-compute the prefix array for the function. Okay. Okay. Yeah, I hope this is clear. So we can just look at the code now.
Sir,
Yeah.
before course, please make a prefix array by taking a small test question.
Okay. Okay. It's like for this test case only, I would try to make you understand. So for
Yes.
5 to 9. Okay. So you had the range L equal to 5, R equal to 9. So you wrote the numbers 5, 6, 7, 8, 9. So like in pre-computation, you would not compute just for 5 to 9. You would compute from 0 to 1e5, whatever range constraint is given in your problem. So if you are computing for all the range, so first you would compute the function. So for 5, so you are computing from 0, 1, 2, 3, 4, 5, this full range. Up till 1e5 you are calculating. Okay. So for 5, how many steps it takes? It takes 2 steps. So f of 5 would be 2, f of 6 would be 2, this would be 2, this would be 2, this would be 3. You can write it for this only. 0 would take 0 steps, 1 would take 1 step, 1 step, 3 would take 2 steps, 4 would take 2 steps. So you have calculated the function for all the values. Likewise, you would calculate. Now you would take the prefix sum of these values. So to take the prefix sum, you would write prefix. So 0 would remain 0. Prefix of 1 would be 0 plus 1, 1. Then 1 plus 1 would be 2. 2 plus 2 would be 4. 4 plus 2 would be 6. 6 plus 2 would be 8. Plus 2, 10, 12, 14, and plus 3, 17. Likewise, this would be your prefix array. Okay. And once you have computed your prefix array, now for every test case, you have a test case for L equal to 5, R equal to 9. What you would do, you would write your answer as f of L. So f of L was f of 5 into 2 plus prefix of R, which is 9, minus prefix of L, which is 5. So what you would get here, f of 5 was 2, 2 into 2, plus prefix of 9 was 17, and minus prefix of 5 was 8, minus 8. So you would get 4 plus 17, 21, minus 8, 13. So you were getting 13 here. So again, you have got 13. So I hope it is clear how we are doing it.
Yes, sir.
Okay.
Sir,
Yeah.
sir, if you would increase a single element, like if while reducing 5, we kept on increasing 6, not 7 and 8 and 9, then it would be wrong, right?
Like what?
Like
I don't
uh,
understand.
I'm reducing 5 to 0
Yeah.
and increasing only 6,
Yeah.
then what would happen? Like that would be
Uh,
a wrong approach.
it would be the same thing. Like if we are reducing 5 to 5 to 1 and 1 to 0, it is taking 2 steps. For those 2 steps, you need to you can select any one of them as your X. So you can increase this 6 to 18 and then 18 to 54. You can apply both the operations on this 6 only, or 1 on 6 or 1 on 7. It would not matter, because if you are increasing this 6 to 18 and 18 to 54, now to reduce this to 0, it would take 2 extra steps. Okay, and the 7
Yes.
take 2 steps only. And if you are doing one operation on 6, one operation on 7, then a +1 would be added to both of them. So finally, net, if you are if 5 is taking 2 steps, then it would increase 2 steps for any two of them, or uh, +2 for any one of them. So like you can do that operation on any one. It doesn't matter. Okay.
Okay, sir.
Okay. Now we can look at the code for this. Okay. So first thing I'm doing is just calculating the f that I told you, the function, how many steps it is taking for an n to get reduced to 0. So this I'm doing through a recursion. So if n is already less than 3, then we can say that in one step it would get reduced to 0. So this would be my base condition. Otherwise, I would say 1 plus calc n by 3. So through this recursive function, I'm reducing n by 3 and adding a +1. So through this recursive formula, we can just calculate how many steps n is taking to get reduced in log base 3 time complexity. Okay. So this is the first function that we created. And we need to pre-compute the prefix array. So we have taken a global prefix array, and what we are doing. So I've taken 3e6. We can take 3e5. So it was 2e5. So you can just take 2e5. I've taken some extra. So no problem. You can reduce this to 2e5. There would not be any problem. Yeah.
Here, what is first ISO? In line number 114. What is
100.
first
Okay,
ISO?
like you can ignore that fast IO if I show you, that is just for making the input fast. You We add these 3 lines to make input output fast. So you can ignore that. That won't make much difference, but it just increases the speed of your code a little bit. Okay. Now, what we are doing, we would assign the prefix array to 0. We would initialize it with 0. Uh, we are taking the size as 3e5. 2e5 plus 1 would be fine. I'm taking just some extra. Okay, so prefix of 1 would be 1. So that's you can see, for prefix of 1, my function would be 1 and my prefix would be 1. After that, I'm just calculating through the formula that prefix I is prefix I minus 1 plus the function of I, the calc of I, number of steps I would take. So this way we are computing the prefix array. So I hope that is fine. So we have pre-computed the prefix array. Now we would go to every test case. Okay. So we are handling
Sir,
every test case here.
but
Yeah.
but when calculate function call each time, sir, then it
Yeah.
takes not more time.
The calc function is taking log n time. So its time complexity is log base 3 of n, basically. So overall time complexity would be 3e5 multiplied by log of 3e5. So log of 3e5 would be very less, like 15,
Yes.
20. So that would not make much of a difference. Okay. It's n log n.
Okay, sir.
So we have pre-computed this. Now for every test case, we have taken L and R as an input, and final answer as I wrote the formula. The calc of L multiplied by 2 plus prefix R minus prefix L. as I had wrote in the explanation, just print that. Okay. So I hope this problem is clear now. Okay, I think I had explained the time complexity for brute force, why it is failing. You can just rewatch that if you have a doubt, and how I have pre-computed to manage that. Okay. Prefix 1 equal to 1, like I explained here. You have for prefix 1, the value was 1. So that I have taken as a base condition to calculate the other prefixes. Okay, so now let's move to the next problem, which is problem F. Okay. So problem F, we have given a binary array A of length n. He will take all subsequences of length k, where k is odd of this array, and find the median. What is sum of all these values and output it modulo 1 in 9 plus 7. Okay. So in this problem, what we are given, that we are given a binary array of length n. What does binary array means? It would only contain either 0 or 1 as its elements. So we are given some binary array. Along with that, we are given a k. So let's see what we need to find. Let's take the first test case only. Okay, so we are given this k and a binary array. So we need to find for this binary array, if we take all the subsequences of length k. So I had explained in an earlier question what a subsequence means. So I'm not going to explain it again. So if you take all the subsequences of length 3, what all would it be? Let's take. So it's a 4 length array. So to take all the subsequences, I can just remove any one element. So if I remove this, it would become 0, 0, 1. If I remove this, it would become 1, 0, 1. If I remove this, 1, 0, 1. If I remove this, 1, 0, 0. So these would be the only 4 possibilities for a subsequence of length 3. Now for all these subsequences, what we need to do, we need to find the median of that. Just find the median of each subsequences and calculate the sum of them. So what would be the median of this subsequence? So what does median means? Median means for any array, if you need to find the median, first thing is sort the array and then take the middle element. That would be the median. I hope you know that. Okay. So if this is the array, if you sort it, it would remain 0, 0, 1, and the middle element would be 0. So its median is 0. If you look at this array, if you sort this, it would become 0, 1, 1. Middle element would be 1. Its median would be 1. If you sort this, it would again become 0, 1, 1. Median would be 1. If you sort this, it would become 0, 0, 1. Middle element is 0. Median would be 0. Now, sum of these would be 1 plus 1, 2. So 2 would be your final answer for this test case. Okay. So 2 was the answer for this test case. So I hope the problem is clear what we need to do. We just need to take all the subsequences of length k, find its the median of for every subsequence, and then sum of those medians is what we need to find. And we are given that this sum can be very large. So take it modulo 1e 9 plus 7. So while summing them up, we just need to take modulo 1e 9 plus 7 so that if its answer is exceeding 1 in 9 plus 7, it's reduced below 1 in 9 plus 7. Okay. Now, this is the problem. So how can we solve this? So first of all, if you just think of a brute force approach to take all possible subsequences of length k. So the possible number of possible subsequence for an array goes the order of 2 to the power n. So doing the brute force approach would be a time complexity of 2 to the power n multiplied by n basically, or k, for checking it or finding the median. So that would be anyways very large. We are given kn and as 2e5, and we are also given k is odd. Okay. So we need to optimize it. So what we can do here is, the first thing you look at it is, it's a binary array. So it would only have 0 or 1. So to calculate the median, what do we need? For a binary array, what would be the middle element? So if the array has X number of zeros and Y number of ones, so let's say for this array 0, 0, 1, it had two zeros and one 1. That's how you can represent this. So two zeros means 0, 0, 1. So if the array has more number of zeros than ones, its median would be 0, middle element would be 0. If the array has more number of ones than zeros, its median would be 1. I hope this is clear. Because to calculate the median, if the middle element is a 1, then it would be a 1, otherwise a 0. And when would the middle element be a 1? When it has more number of ones than zeros. Okay, if number of ones are more, then its middle element would be 1. Otherwise, there would be more zeros. Because in sorted order, there would be zeros, some zeros, and some ones. Okay, so when would the number of ones be more? uh, we need to find subsequences of length k where k is odd. So for odd k, we would have a middle element all the time. So let's say if k is 5, then when would the median would be 0 and when would it be 1? So if we have if this case where there are three ones, then its median would be 1, middle element is 1. If you have more ones, still it would be 1. But if you have three zeros and two ones, its median would be 0. So basically, if you have at least three ones, then I can say its median would be 1. So if number of ones is greater than equal to 3, then we can say median would be 1. Else we can say median would be 0. Now what is this 3? How we got this 3? For k equal to 5, it was 3. What would be for k equal to 7? 0, 0, 0, 1, 1, 1, 1. At least 4 ones would be required. So basically it's k by 2, 7 by 2 is 3 plus 1. If you do the floor division, or you can say the seal of k by 2. So for any k, let's name this k by 2 as something the required number of ones. Okay. Let's say the required number of ones is going to be k by 2 plus 1. If the count of ones, let's say C1 represents the number of ones in a subsequence. So if the count of ones is greater than or equal to required, we would say that the median is 1. Okay, now, but still the problem is we cannot uh, count it for every subsequence. We cannot create all the subsequences because it's going exponential. So we need to apply some, I think PNC to calculate PNC to calculate in how many cases we would have a 1. Because for our final answer, we just need to find how many subsequences exist where the count of 1 is greater than required. For those subsequence, we would add a +1 to our answer. For remaining, we would add +0 to our answer. So we just need to count how many valid subsequences exist where the definition is valid is that the count of ones is greater than the required. Required is basically k by 2 plus 1. Okay. So that's what my question is reduced to. So how can we do that? Okay. So if you look at an array, okay, if this array is 1, 0, 0, 1, and k was 3. So required value was for k equal to 3. It's 3 by 2 plus 1, which is 2. Okay. So we need to find how many subsequences of this exist such that the number of ones in that subsequence is greater than equal to 2. So how do we make a subsequence? So do we make a subsequence of length 3? We select any 3 elements from out of these 4 elements. So there are 4C3 ways you can say to select a subsequence of length 3 from an array of length 4. Now, among these 4C3, how many of them would satisfy this condition that the count of 1 is greater than equal to 2? So for that, we can just check in our actual array. Let's name CNT1 as the number of ones in our actual array and CNT0 as number of zeros in our actual array. So in our actual array, there are two ones and there are two zeros. So we need to have number of ones at least two. So if we have two ones, let's suppose, so then among these two ones, we need to select both of them. So 2C2, and among the remaining zeros, we need to have a total of length of 3 basically. So we would select among the remaining two, we would have to select one element. So our answer would be 2C2 into 2C1, which is 1 into 2, which is 2. So that's what we were getting. Like for this example, if you can understand, we would generalize it for any general to get our formula. So how can we generalize it? So if in an array, I'm saying the count of 1 is CNT1 and the count of zeros is CNT0. Okay, for a n length array, we can calculate the count of 1 just by iterating, and we can say n minus count of 1 as the count of zeros. Okay, so we have calculated these two values. Then what we need to find the number of valid subsequence. So we are given a k, and a required value would be k by 2 plus 1. We have calculated these two values. So what we need is for the subsequence, we need to have at least this many ones and remaining should be zeros. So one possible scenario is among count one elements, select required number of ones. I hope you can understand that number of available ones is this much, and we need this many ones. Multiplied by number of available zeros is this much, count 0. And how many do we need to select? We have already got this much. So k minus required is the more that we need to have. This is the scenario for exactly required ones. So if you want to have exactly this many ones, this would be the number of ways. Now you can also have required plus 1. You can have more than required. That is not a problem. You can, the number of ones can be more than required. If required is 3, you can have 4 ones, 5 ones, 6 ones. That is also okay. So basically you need to iterate for every I from required to at max how many ones you can have. Count 1 would be the maximum number of ones you can have, or if k is the maximum like you are taking, so you can write is a minimum of count 1 or k. Okay, that can be managed. Okay, so for every I you would iterate, and you would say that answer in your final answer, you would what you would add, required would be replaced by I, because you're iterating. You can have required also, more than required also. So CNT1 C I multiplied by CNT0 C k minus I. So through this, you can just calculate. So you can just write this formula that for I number of ones, this is the number of ways. Then you iterated for every I greater than equal to required and added your answer for all those possibilities. Then you would get your final answer. Okay, so I hope this is clear. Now,
Sir,
yeah,
can you repeat what? Can you repeat once your
yeah. So,
explanation?
okay, so like in the example that I explained, that was clear why we wrote this.
Uh, Sir, no, sir. 2C2 into 2C1. Why you write?
Okay,
Please.
okay, I'll explain again. Okay, so let's suppose I'll take another example. You have this as an array, and you have k equal to 3. Okay, so what you need to find the number of subsequences where there are at least how many ones. The required number of ones is k by 2 plus 1. I hope that is clear why I have written k by 2 plus 1. So this
Yes,
would
sir.
be 2. So you need at least 2 ones. So we can have the number of ones can be 2 also, can be 3 also. There is no, if you have all the 3 ones, in that case also you would have a subsequence where the median is 1. Okay, so we would write for every case for where we have the number of ones is 2, the number of ones is 2, 3. We can have 4, 5 also, but we need to find an array of size 3 only, and there are at max 3 only. So writing 4 and 5 are irrelevant here. So only 2 and 3 we would check. So for 2 ones, how many ways can be there? So there are 3 available ones. So among 3 would select any 2 of them to be the one in our final subsequence. And we have selected 2. We need to find an array of size 3. So 3 minus 2, 1 is still remaining. Okay. So among zeros, we would select any one. So 2C1. Okay. So we had 2 zeros. Among that, we would select any 1 0. So 3C2 into 2C1 would be the formula for, would be the number of subsequences where there are exactly 2 ones. And where there are exactly 3 ones, so select all the 3C3. And among the zeros, there are 2, but you don't need to select any because you have already selected 3. So I hope this is clear. So
Yes, sir.
3C2 would be 3 into 2. It would be 6. And in this case, it would be 1 into 1. It would be 1. So 6 plus 1 would be 7. So 7 would be our answer for this test case. Okay. So this only we have generalized it as a formula. What I wrote, uh, I have iterated for all the I from required. Required was 2 up till either k or the number of ones. So I have iterated from required to minimum of count 1 or k. Okay. So I have iterated through this, and for every I, what I am writing, what was this 3C2? Number of available ones, which is count 1, C, I. So this 2 got here. So count 1, C, I. And then what was here? The number of available zeros, which was 2. So count 0 here. C, K minus I, because you need to find a subsequence of length k, and you have already formed 2 elements from that, I elements from that. That's why k minus I, which was 1 here. So this is the formula we wrote here for a generalized case. I hope this is clear now. If count 1 is 0, like we can manage those cases that if count 1 is less than required, then we cannot form any subsequence. So then we would return a 0. Okay, so that you can just handle before only, that count 1 if count 1 is less than the required, then we can just return 0 in that case. Okay. Uh, so now I hope this is clear. Now, how would we efficiently calculate this? Because how do you calculate NCR efficiently? Because if you just go for the brute approach, NCR using DP would go N into R. Okay. But, or if you know the formula for NCR, it's NCR is actually n factorial upon n minus r factorial into r factorial. That's what it is. So if you just try to calculate this n factorial, it would take O of n, and these would take O of n r. Okay, so this calculation would also take O of n. And we also need to maintain modulo m thing everywhere. So what you can just do is you can just calculate this factorial. You can pre-compute this factorial thing before only. So you can just pre-compute the factorial for every I. So for every I, for the constraints that we are given in the question, what we are given, n can vary up to 2e5. So just pre-compute that for every I from 0 to 2e5. Just pre-compute your factorial modulo m. Just do a modulo m everywhere. You can just calculate fact I as fact I minus 1 into I modulo m. So this way you can just pre-compute your factorial beforehand. So now when you need to write the NCR, you can just write NCR as factorial of n divided by factorial of n minus r into factorial of r. But here, since you are also doing modulo m, so you cannot divide like this. You would have to use the modulo inverse. So if you know about modulo inverse, so basically instead of dividing it, what you would write fact n multiplied by modulo inverse of fact n minus r into fact r. So you would have to do the inverse of take the modulo inverse of this and mod m. So this way you would calculate the NCR efficiently. So once you have pre-computed the factorials, this inverse inverting it would take log n time. So log n is not much. So this NCR can be calculated in log n time. Okay. This NCR is calculated in log n time. And if you just pre-compute the inverse, this log n can also be reduced to O of 1. Okay, but I've done in log n also. You can just optimize it to O of 1 by pre-computing the inverse also. So that's for NCR. And what we are doing, we are iterating for every iframe required to count. So this I would be at max go O of 1e5, and this NCR is calculated in O of log time. So in n log n time, basically we are computing everything. So this would be fine. We can look at the code of this if there is no doubt. Okay, so first we would pre-compute the factorial. I have taken this factorial and I have pre-computed this. Sorry, I removed it from here. Just a second. I'll show you the code from here. Okay, I've taken the factorial and I pre-computed this factorial. This is basically a loop from 1 to n. Ignore this rep. It's a loop from 1 to n. So what I'm doing here is, this is visible now, or I need to zoom it more. Okay, I hope it is clear now. So I'm pre-computing my factorial here. Fact I is fact I minus 1 into I mod m. So this way I'm pre-computing my factorial. Okay, now once this is done, so I'm moving to every test case. Here I've taken n and k as input. I've created my NCR function to calculate. So if r is greater than n, I'm returning 0 here. So I would manage any case where I'm getting some values where the required is more than n, I'll be returning 0. So that case I'm handling. And modulo division of, so I've created a modulo division function. What it is doing is, uh, it's just calculating p by q mod m. So p multiplied by modulo inverse of q. Modulo inverse of q is q to the power m minus 2. Okay, so power m is the binary exponentiation. So I hope if you have studied the number theory things, you would, that is not a big deal. Okay, so I'm just calculating the p by q mod m through this function. Okay, so I have to take mod m. So I'm calculating p. This function is returning me p by q mod m. Now, what I need to do, factorial of n divided by factorial of n minus r into factorial of r. So this function is returning me the NCR value. Okay. So I hope this NCR is clear. I'm doing it in log n by pre-computing my factorials. Okay, so I've created this NCR function. Now let's come to the actual code. We have taken n and k as input. We have got our input array, and I'm taking the count of 1, which is the count through the count function. I'm taking count of 1, and count of 0 would be n minus c1. And these variables, and k1 is actually the required that I was telling. I have named it k1 here. It is actually the required which I wrote there. Okay, so this required is k1 in my code, and c1 is the cnt1. So now if the count of 1 is less than required, what I told, we would just see out 0 and return. Okay, this base case we are handling. After that, I'm running a loop from k1. This is a loop from k1 to min of uh, k or c1. So as I told there, I'm running a loop from k1, which is required to minimum of count or k. So I'm running a loop from k1 to min of k or c1. And then what I'm doing, answer equal to answer plus NCR of c1 comma I. So uh, c1 comma I, NCR of this multiplied by NCR of c0 k minus I, NCR of this. Okay, modem. So this way I'm calculating my answer and printing my answer. I hope the code is clear. I hope this problem is clear. There's no doubt. So we can move to the next problem. How we're handling when count of zeros are 0. So when count of zeros are 0, C0 would be 0. So in NCR, if C0 is 0 and the required is more, then we would have R greater than N, we would return 0. So this product would become 0. Okay. So that case is handled here through this. If R becomes greater than N, return 0. Okay, just don't count that case. Okay. So now let's move to the next problem. So G1 and G2 are basically the same problem with different constraints. So I'll discuss them together, and I'll also explain how we can solve only G1 and both G1, G2. So, okay, let's read the problem. So this is an interactive problem. Okay, so what we are given here, we have a secret ruler that is missing a number X, and X can be in the range from 2 to 999. So if you look at this ruler, X is 4. So it is missing 4. After 1, 2, 3, there is 5, then 6, like that. So what would happen if some value is measured from this ruler, and that Y is less than X, it would measure correctly. If we have to measure 3, 2, 1, it would measure it correctly. But if we measure 4, a length of 4, it would give 5. Okay, if we measure a length of 5, it would give 6. So for all y greater than equal to x, it would measure y plus 1. And for all y less than x, it would measure y. Okay. Now, in the question, what we are given is for every test case, there is some hidden x. We don't know what the value of x is. We need to find the value of x using some queries. So in one query, what we can do, we can output this question mark and then some values a and b. This in return, it would give us the area of a rectangle having side a and b, side lengths a and b, the area of that rectangle as measured by the scale. So if this ruler is measuring correct lengths, it should return a into b. But if it is not measuring correctly, it would return what it is measuring. So for in this example, if x is 4 and you pass a equal to 3 and b equal to 5, what would it measure? Uh, a was 3, 3 is measured correctly as 3. B was 5, 5 is measured as 6. So it would return 3 into 6, which is 18. So by passing 3 and 5, it would return 18. So these are the queries that I can make, and we need to find the value of x in at most 7 queries for the problem G2, and in G1 we had 10 queries, the maximum number of queries we can have. Okay, so let's suppose we are solving only G1 where we have 10 queries. So how can we do that? Okay, so we are given that first thing that we know that x is in the range from 0 to 999. That's the range of x. So if we have a ruler, okay, where let's suppose we have some x here. Okay, this is some value of x. So all the values which are less than x, they would be measured correctly. So if we have some value a, which is less than x, it would be measured at as a only. But if we have some value b, which is greater than x, it would be measured as b plus 1. This is what we know. Now, to find this unknown x, we can make queries of the form question mark AB, where it would return a rectangle, area of rectangle. Basically, it just returns A into B. That's what it returns as measured by the ruler. So if both A and B are correct, it would return A into B. If let's suppose B is measured incorrectly, then it would return A into B plus 1. If A is measured incorrectly, A into B, A plus 1 into B. If both are measured incorrectly, A plus 1 into B plus 1. So like these are the only possibilities we can have. Okay. Now, among these possibilities, if you are providing some, okay, whatever A and B you are providing, how can you find X? So in limited number of queries, so we have, let's suppose 10 queries. So the first thing that comes to your mind is some binary search kind of intuition. If you think that your initial range of X is 2 to 999. Let's suppose you take some mid value and just check whether that value is before X or after X. Can we check this using our queries? So if you want to check some value Y, whether this Y is less than X or greater than equal to X, can we check this? We can pass question mark Y. What it would return? It would either return me Y square if this Y was below X, then it would measure correctly as Y square. If it was above, it would measure Y plus 1 square. Okay. So we can just check our output whether it is Y square or Y plus 1 square. That way we can just check whether this Y is before X or after X. If this Y is before X, we would make our range. Initially, our range for low and high was this, was the 2 to 999. We would change our range. Let's say we've got that this Y is before X. It's falling somewhere here, the mid value. Okay. This Y is basically the mid. Okay. So then we would transfer our range to Y plus 1. Okay. We can transfer our range to low to Y plus 1. So we would start searching in this range. We know that X is greater than Y for sure. And if this Y was falling somewhere here, we would transfer our high here and make this range somewhere before Y. We know that X is less than equal to Y. That's why. So through some binary search kind of thing, by checking this, we can just start reducing this range and finally reach this X. Now, if you try to do this, in how many queries we would have to make? So the number of queries you would have to make is you are dividing into two parts. So by two. So initial range is about 1e3. You are dividing it by 2. So in log base 2 1e3 number of queries, you would be able to calculate, reach a final X. Okay. So what is this? This is approx 9 point something. You can say this is less than 10, but it's still greater than 7. So in worst case, like while doing through this case, you would do in 9 or 10 queries, you would be able to do this. So you would be able to solve the problem G1 using this approach, where you are always passing queries question mark YY. But in okay, so this is the approach for G1. I have directly written the code for G2, so I cannot show you the code for G1. I would attach that code in the description for this approach, just G1 approach. So let's discuss the G2 approach also, then we would see the code. Okay. So this was the approach for G1, where you are just doing a binary search kind of thing, reducing the range. So in log base to 1e3 number of queries, which is either 9 or 10, about 10. In 10 queries, you can do this. Now, you need to reduce it further. In problem G2, you are asked to make the number of queries below 7. In less than 7 queries, you have to do. So how can you do that? If you take a look at this, what we have, question mark AB. So here we're using YY. Instead of that, we can use different values. So if we use different values, we already know we would have these 4 cases. Now, from the result, we can identify among these what is the case. So actually, instead of dividing this range into 2 parts through mid, now we would divide this range into 3 parts. So we would take a mid one and a mid 2. Okay, so what we would do, we would divide this range into three parts. So this M1 is the 1/3 part of the range, M2 is the 2/3 part of the range. And we would make a query question mark M1, M2. Now, what would happen by making this query? So, if we are making this query, what cases can we have? Let's say we don't know X. Either X would fall in this range or this range or this range. If X is in this range, both M1 and M2 would be uh, false values. So we would get, so if X is falling in this range, for this range, we would get M1 plus 1 into M2 plus 1. This is the answer we would get for the query if X is in this range. If X is in this range, M1 would be measured correctly, but M2 would be measured wrongly. So M1 into M2 plus 1. And if X is falling in this range, both M1 and M2 would be measured correctly. We would get M1 into M2. So by looking at the result of this query, if its value is this, we would say my X would fall in this range. I would make my low as M2 plus 1. I would transfer my low here. So I would say that now check for this range only. If I get the value of my query as this, I would transfer my low here and high here. So I would check for this range next. If I get the answer for this, the query as this, I would transfer my high here and check for this. This way, always I am dividing my range by 3. Now, what would happen by dividing the range by 3? Initially, I had a range of around 1E3. Now, if I divide it by 3 at every step, so basically in log base 3, 1E3 steps, I would be able to reach a single value of X from a range. And what is this value? This is approximately 7. It is less than 7. So in 7 queries, we can do this by dividing my range in 3 parts. I hope this is clear to you. So what we are doing here, I'm explaining it again. We are doing a binary search kind of thing, or you can say a ternary search kind of thing here, where we are taking the initial range as low equal to 2 and high equal to 999. And then we are calculating mid 1 as 1/3 of this range, mid 2 as 2/3 of this range. And then we would make a query of M1, M2. We would check the result of the query. If the result is this, I would say my X falls in this range, reduce the high to here. If the result of the query is this, I would say X falls in this range, make low here, high here. If the result of the query is this, I would say X falls in this range, make low here. Okay, so that's what we are doing. And in this way, in log base 3 of 1E3 steps, which is approximately 7 steps, we can calculate our final X. We can find out our X. I hope this is clear. So we can look at the code for this. Okay, so you can see the code. I took a low equal to 2, high equal to 999, and while low is less than high. When would we reach a single value? When low and high would become equal. So until low is less than high, we would run our while loop. M1 is low plus high minus low by 3. So low plus this range by 3. So 1/3 of this range is M1. M2 is 2 times high minus low by 3. So 2/3 of the range added to low would be M2. So we have found our M1 and M2. We would do the query of question mark M1, M2. This is the query we did. Now we got the result through cin in res. We would check if the result is M1 into M2. What was M1, M2? This result. If we got this, we would change our low to M2 plus 1. We would change our low to M2 plus 1. If we got the result as M1 into M2 plus 1, which is this, then we would change low to here, M1 plus 1, and high to M2. Low as M1 plus 1 and high as M2. Otherwise, for the third case, For this case, we would change high as M1. So we would change high as M1. So this way we are changing our range. Finally, when we come out of the loop, low and high would be the equal. So we can either print low or high, both of them would be equal as our final answer. Okay. So I hope this problem is also clear to you. Okay, is there any doubts? Okay, so we can end the session now. We have discussed all the problems. So thank you very much for tuning into it. Goodbye.